Oh, hello. Can you actually hear me? Please type a simple yes in the chat.
Yes, I can hear you, but I can also type. Just a moment.
Just a second, Michael. I'll switch off. Okay, excellent. Okay, so let me explain how we're going to do it today. So because we would like to offer you two different options, so you can either follow the presentation on the GoToMeeting. However, I can say that there could be some issues due to the internet connection, so there can be some delays and some freezes in the videos. Or as a second option, I posted in the chat a direct link to the presentation, which you can open. And in the meantime, it will be downloaded. So you'll be using it in a passive mode. So I will still be able to control it for your needs. And if you don't use a limited internet connection, or you're watching the presentation from your phone, or so if you're not watching it from your phone or a tablet and by using a desktop or a laptop, then I would strongly suggest you to do so, because in this case, the quality of the presentation will be much better. So I will post the link once again. It is also up there, so you can, somewhere here. So you can open it and download the presentation.
Dimitri, maybe you tell them again the link of the Prezi, because I cannot read it very well.
Mm-hmm. Yeah, I just posted it once again in the chat. So please open the chat. Yeah. So there is a link to the presentation. It may take a while for it to be downloaded, but overall that should work better than just a simple screen that we have in the GoToMeeting program. So please give me a short answer. Have you tried to open the link? A simple yes in the chat will be also sufficient. Okay, it works for the Michael. Yeah. Yes, it may take a while for the presentation because of its size. So once you open the presentation, please confirm it once again in the chat. Okay, great. Okay, so my name is Dmitry Kushnikovsky, and I would like to welcome you in our first OPT, or online partner training this year. And I think right now we will hear also some welcome words from the Mikhail, and we will be good to go.
Yeah, thank you, Dimitri, for the nice introduction. Buenos dias to what I see just at the moment, to Brazil, and to buenos dias to Peru at the moment. Nice that you are there, Victor. I know you are very busy. And also welcome to our neighbors in Poland that you attend the meeting today again. And I hope we will have also a lot of other participants during the meeting. The meeting is maybe today a little bit long because we would cover all topics what we have in our product range. You can see in the background of Dimitri the topics what we would handle today. And for me, it is very pleasure to welcome Dr. Dimitri Kushnikovsky in our company now as the new head of development in leXsolar, and he would introduce you very careful and very professional in our product for the TVET customers. So I think that's enough. We don't need to talk so much about leXsolar. Everybody of you know what leXsolar are doing, and I would give the presentation in the hand of Mr. Dimitri.
Okay, thank you, Mikhail, for the nice introduction. So yeah, let me just say it once again. So my name is Dmitry Kushnikovsky, and I work in the product development here at leXsolar. So today we have a little bit unusual presentation because we're going to present you most of our products, and especially the products which are dedicated for the technical vocational educational training. So let me just briefly start the presentation. So I hope you have downloaded it. Oops. Oh yeah, here we go. So that you can also share, so you can also tell the screen, and you can see me on one part, and you can see the presentation on the other part. Okay, so let's get us started. So you are familiar with leXsolar, and you know that we are focusing on the products which are oriented on the renewable energy, so different kinds of energy, and today we are going to present you most of them. So yeah, as I mentioned, today we are focusing on the professional series, meaning that the products which are suitable for the colleges, for the professional schools, in different subjects, starting from the electrical engineering up to chemistry, physics, or chemical engineering, as well as some other areas. So these products are suitable for the level 2 to 6, according to the International Standard Certification of Educational Training. And they're oriented for the students so that they can get a basic understanding of physical principles, as well as get more sophisticated insight on the applications from the renewable energy sources. Okay. So yeah. Also, if you have any questions, you can also type it in the chat. We will do several stops because we have lots of products to present today. And once we finish with one area, I will answer your questions. So yeah, besides the hardware, we also offer a complete solution for both teachers as well as the students. With different kinds of experiments, and for every single product, it's somewhere between 5 up to 30 different experiments. Okay, so we also have trainer packs which include several kinds of possible products which are suitable to supply basically the whole training lab of the professional schools and or vocational schools. Okay, so on the following slide you can see, I hope you can see. Okay, it's coming, yeah, you can see. So you can see the idealistic world, basically. So where the whole energy is supplied by the renewable sources. And we are, at leXsolar, we are proud to present our products designed for the education in these areas. So we will cover today several topics, starting from the solar energy, then we will go to the hydropower, also to some energy storage technologies. Then we will cover a certain area which is called a smart grid, or a smart power consumption and a smart supply for the households. Then we will also go to the areas of the electrical mobility, and we will finish in our environmental section, which are the products of the biofuel and vehicle and biofuel and bioenergy. And I will also explain everything in detail. So the presentation is organized in such a way that we will briefly cover the theoretical part if it's needed. And then we will see also the content of every single case. If you have any questions, we can also do it live. We have our product standing right next to me, so we can open it. So we can have a look. We can have a close look to it if it's necessary. And we will also see a couple of experiments for every single case. Okay, so let's get started, and we will start with the photovoltaics. That means with the solar energy. And why solar energy? Because it virtually have no limits in terms of the energy supply. However, in spite of this fact, it's still ranked only third in terms of the energy production from the renewable energy sources. However, just a small percentage of the Sahara Desert covered in solar cells can supply the whole globe with the renewable energy. Why we don't do so? Because of the cost, of course, and policy, and because some of the technologies are also more suitable in different areas, for example, hydropower or wind energy. Okay, so how does the photovoltaics works? And based on a principle of the so-called the photovoltaic effect, and the solar cell typically consists of the silicon, so with several kind of dopants. So the most common P-type dopant is a boron, and the most common N-type is a nitrogen. So that means we have a stack of two different semiconductors, P-type and N-type, together forming sort of a sandwich. And upon irradiation with the sunlight, there is photons. Basically, they're hitting the N-type. The N-type of the semiconductor, therefore transferring the and if the energy larger than the band gap, or larger than the energy level required, the transfer of energy from the N-type to the P-type, the electron is hit from the silicon orbital of the P-type semiconductor, and is released to the N-type, so which is called the PN transfer or PN type transition. And then electrons are going into the circuit. So there are several kinds of solar cells designed all over the years, and the first generation was, and which is still is the most popular type of the solar cell, which is based on silicon. Different silicon can be used, a polycrystalline or a single crystalline, and the researchers started somewhere in the 70s or even before this time, and since that time, they are the most commonly used and occupy probably 70 to 80% of the market right now. However, the average efficiency of the silicon solar cells do not. Yeah, it's around 13 to 20%, depending on the chemistry, depending also on the junction. So for the single junction, single and polycrystalline silicon cells. The second generation was using the so-called thin film solar cells, which have been developed in 1980s, and still quite a hot topic so far. And the third generation, which are based on mostly based on the so-called perovskite or perovskite type of structure, which is a specific crystalline structure similar to the calcium titanate. It's a really hot topic. So, and since the beginning, it was they started with the efficiency of around 5%, and now they are reaching 20–25%. And right in December last year, so the record was set. So there is a record efficiency, which is currently is 48.3 or 6%, if I'm not mistaken. So that was a multi-junction solar cell produced in Fraunhofer University in Freiburg, Germany. It's still that's still experimental one, because yeah, and it's it will take a while if it ever hits the production. Okay. So yeah, as I mentioned previously, the solar cells based on silicon chemistry are still occupying most of the market, and they are reaching approximately 80 to 90% even so far, because of the production cost and because of the technology. Okay. Since the discovery of the solar cells, they have been used in portable devices, like you can see calculators. Later on, they have been applied on a roof of the regular households, or in photovoltaic power plants, or even at the International Space Station for generating the energy, the electricity. Okay, so now we will have a look on, oops, I'm sorry. Oh, yeah. Yeah, now let's have a look on the leXsolar PV Professional, so where the PV stays for the photovoltaics. This is our product, which is specifically designed for electrical engineers, as well as, well, not only for the electrical engineers, but for the training in electrical engineering, as well as physics and environmental science and renewable energy. So depending on the level, it can be used for the basic training, or as well as high school training and vocational training. So it's designed so that the students can get an understanding of the basic physical laws, also working principles of the solar or photovoltaic cells. And it's a product which is also ready to use, because it's supplied with everything you need in one single case. So the whole laboratory basically in one single case. Also, please type and please let me know if I'm rushing, and you can follow me, or I am somehow yeah, going before the presentation, please let me know, and I will slow down. So the question is what we can do with it. To answer it, we have to take a look on a curriculum, because as I mentioned previously, for every single case we have several kinds of manual supplies for both teachers as well as the pupils or students. And for PV professionals, there is also a curriculum written, so which covers several topics that you can see on your screen. It covers from the fundamental physics, starting from the Ohm's law, series connection, parallel connection of the solar cells, also basic principles, working principles of the solar cells, and as well as introduction to the smart grid and also the energy supply of the households. I will also forget to mention that at the end of the presentation, or within several days after it, you will get a link, so you will be able to download this presentation. Okay, so now let's have a closer look what we have. So as you can see, we have lots of modules and components for this case. And we will start with a solar cell, or photovoltaic cell if you want. There are three different kinds of it supplied. So we have three small solar cells, three average solar cells, and one large solar cell. And they are different in terms of the IV characteristics, output voltage, current, and therefore power, and of course the size. The next component, the next module, is a light bulb module, which is to simulate the consumer. So for the same purpose, there is a motor module supplied, and as well as a potentiometer, so that the load can be regulated to simulate the consumption of the, for example, a household. So a diode module to assure the unidirectional flow of energy from the solar cell to the consumer. A shunt regulator, which is used to protect the batteries from the overload. So there is a critical high what value as well as a lower value set for it. So, and upon reaching this limit, it will shut down the circuit. So it will close the circuit. Therefore, the battery will not be overloaded. As well as a deep discharge module, which protects the battery or energy source from the deep discharge. So yet again, one of the consumers. So in this case, we have a LED module. And our leXsolar AV module, so which is designed to measure either voltage or current, or simultaneous measurement of the voltage and current. And of course, the leXsolar base unit, which can fit up to 4 different modules in parallel or series configuration. And the capacitor module is plays a role of the energy storage, as well as a series regulator model, which is similar to the shunt model. And also a DC-AC inverter, which is a DC-AC bus, which transforms the DC current into the AC current. So the voltage, I believe in this case, is fixed to 2.5 volts. However, you can regulate the frequency, the current frequency, so in the region of 0.5 Hz up to 15 Hz, and the resulting EMF in the first approximation is almost sinusoidal. And MPP tracker, where MPP stays for the maximum power point, which can work in two different modes, either a fully automatic mode, when it searches through the values and automatically determines the point where the power input to it is the maximum, or in a manual mode, where this value can be set manually. A pulse width modulator, which is capable of loading the battery not in a constant way, but by short pulses of a certain frequency. And also some resistor plugs, also cables, and the short circuit plugs. Okay. So let us see some experiments. I hope if it works. So on the following slide, you can see, for example, the model of the installed solar cells on the roof of the regular household. So, and the energy consumption of this household is a combination of the off-grid photovoltaic cells as well as on-grid or regular power plants, or that means that the part of the energy is also supplied by the regular power plant. Okay, so let us see the first experiment, which is the basic series connection of the solar cells. Oops. Okay, now it's working. For this experiment, we will need a leXsolar base unit, as well as three small photovoltaic cells, 3 short circuit plugs, and a couple of safety cables, which uses the regular 4mm plugs that is commonly used. So the series connection is also indicated in every single model by this silver wiring, silver-colored wiring. So by short circuiting it, we can measure the voltage of the solar cell, as well as the current. So we can reproduce it for the series of the solar cell connection, and the students will be able to see how these values are changing. So that, for example, we have an increase of current by serial connection of the solar cells. And the same can be performed for the parallel connection. We can also measure a voltage, and we can by reproducing the same experiment. I'm sorry, I just have a question. So, can you see the presentation? So, do you experience any problems with the presentation, any freezes or delays? So, please answer in the chat. Okay, good. Then it's only with me, I believe. Okay. Yeah, I believe only solar panels. Okay. That means that you're looking in the GoToMeeting only. Okay, so I will post a link right now in the chat, yet again. So this is a link to the presentation, which you can open, and at the same time, you will download the presentation. So you'll be able to see it in a passive mode, so I'll be still controlling it. But in this case, you won't experience any freezing or delays of the video, because I don't know now, I don't know why, but for some reason, yeah, it freezes. So yeah, if you have a possibility, then once again, I would strongly suggest you to do so. So to open this link and open the presentation. Okay, so the next experiment is about the parallel connection of the solar cells, which we will skip due to the timing, I believe, and we will go to the next one. So yeah, please keep in mind that due to the time limitation, I'll be able to show you only a couple of experiments for every single case, and that for the PV professional, we have probably 20 more experiments that I'll be able to show you. Okay, so yeah, we'll skip the parallel connection and we'll go to the next one, which is about the shading of the solar cells. I'm sorry, I'm experiencing some technical problems. Okay. Okay, yes. So in this case, we have a series connection of 3 different solar cell modules, and as well as the AV meter in the end, which we are using for measuring of the current as well as the voltage output of them. And then by covering the solar cell, you can see the drop of, in this case, we're measuring voltage. No? The drop in the voltage, because that means that the cell is temporarily shut down and it does not produce any electricity. So this experiment can also be, it's a sort of a simulation of how the solar cell behaves within a daytime, because as you know, the maximum production of electricity from the solar cells is somewhere around noon, and as well, they're only able to produce electricity somewhere between, depending of course on the time, the season, somewhere between 7 a.m. up to 7 p.m. Okay. Okay, the next experiment. In the next experiment, we will be using the large solar cell, and as well as a lamp that which you can see. So for a simulation of the sun. And in this experiment, we will try to reproduce the regular supply of the household, so for example by the solar cells. So of course it's quite logical. So when the solar cell is irradiated by the sun or by other energy or by the other light sources, so it starts to produce electricity, also which you can see by the rotation of the motor module of the propeller. If we connect an energy source before the consumer, in this case it is a capacitor. So the capacitor will be charging or discharging, depending on the irradiation. And for the protection of the capacitor from the deep discharge or from the overload or from the overcharge, we can also use several modules. So the first one is a shunt regulator, which is installed to protect the capacitor from the overcharge. You can see it as a module which is installed on the very left position. And now we will connect the deep discharge protection, so which will also protect our capacitor from the deep discharge. So it will automatically shut it down when the capacity or the voltage reaches the certain limit. So this was basically a simulation of the electrical system and most of the electrical components, security components, which are installed to protect the energy sources as well as to protect the grid. Okay, so this was it about the solar cells and photovoltaics. Do you have any questions? So please answer me in the chat. You can also ask me the questions anytime. So are there any questions? Yes, we do offer a curriculum. Okay, so no questions. Good. Okay, so I would like to remind you, so I will post a link once again. So that you can download the presentation, and in this case you won't experience any freezes or delays, because you'll be looking at it not from the capturing of the screen, which we have at the moment in the GoToMeeting, but you can open it as a separate browser. So in a browser, and you will see it. Okay. So if there are no questions, then I would like to go to the next topic, which is our next product, which is the leXsolar thermal energy. So, how does the thermal energy work? It basically used in two different ways. And the most common way is that we have a piping system, or we have a tubing system placed somewhere on black material, so which is absorber, and as well as these pipes are also covered in some with some paint or some material which also absorbs energy, so that there is a heat exchange between the solar energy and the material which also flows through the pipes. The most common one is, of course, to use water. So let us see one of the examples, which uses the steam produced. So you can see on the left-hand side parabolic mirrors, which are installed for the concentrating and for the focusing of those of the sunlight, so that there is also a pipe installed on the focus plane of the parabolic mirror, excuse me. So which heats this liquid flowing through the tubing system, through the heat exchanger, which also heats up the water. Water evaporates and starts rotating our generator, which is in this case is a steam turbine, therefore generating the electricity. This is one of the examples how the thermal energy or sunlight energy also can be used. Okay, so that's enough is theory, and right now we go to our product, which is called the leXsolar Thermal Energy Professional, which is designed for the students to get the fundamental understanding of the thermodynamics of processes such as absorption, reflection, or convection, as well as heat conduction or thermal conduction. Also, the basic understanding of the thermodynamic system, open, closed, and isolated thermodynamic system, that they will get familiar with heat storage materials, also heating processes, as well as the focusing, defocusing of the sunlight, and thermoelectric effect, which is known also as a Peltier effect, or an opposite to it, which is known as a Seebeck effect. Okay, so let's have a look what we have inside the case. So here you can see all of the components taken out of it. And as before, we will go through all of the modules and all of the components which we have. So the first one is a thermal collector, which is exactly this tubing system that we talked about. So we have certain pipes in a snake-like configuration to maximize the area. So therefore, the maximum area will be also irradiated by the sunlight. Also a motor module, the regular one, which is a consumer. So a lens module, which is used for the focusing of the sunlight. In this case, we offer the Fresnel lens. Similar lenses are also installed, for example, for the concentrating of the sunlight on the solar cells. Also a parabolic mirror or parabolic reflector for the focusing of the and concentrating of the sunlight on the tubes. And our base unit. So depending on the product, which product is this, we offer different base units. On this picture, you can see a base unit from the ready-to-go series, because you can stick up to 3 different modules on it, as well as a thermoelectrical element, which is also known as a Peltier element, which actually works on an opposite to Peltier method, effect, which is called the Seebeck effect. So that means that if we have a difference in a temperature, it will start producing the electricity, because Peltier effect is based on the vice versa. So yeah, in this case we have a black absorption panel in front and a heat sink in the back, so for the heat dissipation. And also a vessel which is formed by the parafilm, which is filled by the parafilm as a heat exchanger. And for the isolation, the polymer material, the porous polymer material is used. And also a pump module, which is combined with a storage tank, so that the students can also get an understanding of different circulation systems, which are passive circulation, which use pumps, which actually don't use pumps, which just use a flow through the heat collector, and which is, for example, the household, or so that the water is heated and then redirected to the batteries or to the storage, or directly to the consumer. And active circulation, which when we are using pumps and probably also heating elements and or also heat storage or storage tanks. The passive circulation is less effective than active circulation and is commonly used in, for example, in countries which have lots of sunlight, lots of hours of sun. It's less effective, but it requires less material. Also, a thermometer for measuring temperature and a multimeter for measuring current or voltage. Okay, so let's have a look on the first experiment, which uses the Peltier element, so above mentioned. And for this experiment, we will need a digital multimeter, several cables, also Peltier element, a motor module, which also simulates our consumer, and the cooling pack, so which you can see as rubberized piece, with some coolant. Hello, yeah, so please join us. You can also find a link in the chat so that you can open the presentation. Okay, so yeah, in this experiment, we're just simply installing the modules on our breadboard or base unit. So the Peltier element comes up front. The next is the consumer, because the energy is generated by the Peltier element upon the irradiation to the sunlight, or it can be some thermal source. In this case, for the simulation of the sunlight, we are using the infrared lamp. And you can see on the multimeter that the values for the voltage starts to increase from 0. So now it's probably this happens because we have a different temperature. So we have a temperature difference in the different ends of the Peltier element. So therefore, the electricity, the current flows and electricity is generated. which you can see by the rotation of the motor module. So when the peltier element is heated sufficiently, the current flow is also sufficient to start the movement of the motor, which you can see by the movement of the propeller. So you can stop the energy generation either by cooling the peltier elements of the heatsink, so with this rubberized piece, or by shutting down the lamp. So you can see the voltage drops and the motor stops as well. Okay. In the next experiment, we will use the active circulation, which can also be direct or indirect. So by direct, I mean that we're also using pumps, and we use the collector. In this case, this thermal collector, which can be also installed on our base unit. It's also irradiated with a lamp to heat up the water, which is flowing through the pipes. The next model that we need is our pump model, which there's also a storage tank installed, which you can see by this polymer tube. So the power module is supplied. It also allows you to set up a certain voltage which you need. So within the steps of 0.5 volts. And then after all tubings are installed on the thermal collector, as well as our storage tank, we're creating the closed system, so where we don't have an exchange of the matter. In this case, our matter is water, but we do have an exchange of energy, because the thermal collector will also absorb the energy and gives it to water, which is also circulating in the system. So the same principle is used in order to supply the households with water, for example, for the hygienic procedures, cooking, bathing, etc., or heating up the rooms and so on, or regular households. So yeah, now you can see that the system is completely filled with water, and we also need to remove some the residues of air, which is still present in the thermal collector, because air is really bad for the heat transfer. And then by closing the system with this rubberized plug and installing the thermometer inside, we will also be able to heat the water and see the changes. And I should also say that it's not live, and it takes a little bit a while in order to heat it up. But as you can see, the temperature is more than sufficient for the household needs. So for example, for the heating purposes, or as well as for the hygienic purposes. Okay. So this were a couple of examples of the thermal energy experiment. However, I should also remind you that there are many more included. And we'll be going to the most popular, well, probably not the most popular, but to the energy source, a renewable energy source which produces most of the renewable energy in the world, and which is also able for the supply of the whole countries. Okay, so let's see short videos how the hydropower plants actually work. So I hope that you can see it and hear it.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. Mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources,
Okay, so I think okay. Yeah, I think the connection is restored. I hope so. Is it? Okay, yeah, good. So the connection is restored right now. So please type in the chat if it's going good, so that you can see me, you can hear me, as well as the presentation. Okay, it's good. Excellent. Okay, so I also have a question to Ruby Bespoke. Can you please type also? Is there a problem with the presentation? Private answer? Okay, good, great. Okay, excellent, thank you. Even if you missed something from the video, we will discuss it in a minute. Also looking at the experiments. And I showed that in the end of the presentation, with a couple of days, to provide information. So you'll okay. So let me see how it's working. Is there any change in the presentation? Okay. Okay, so now we are moving to the content of our case. So the leXsolar hydropower ready to go. Which is also designed to study as electrical engineering, also energy formation from the renewable energy sources, as well as for physics training, so that the students can understand basic physical principles, as well as to get some ideas on dynamics and what are the current turbine lines and geometries used in power plants. I'm not sure why, but I experience leading on my. Let's see. Okay, I'll have to update it. So for the people who are watching it with only GoToMeeting, it can take a while, but I think it will be working. Okay, good. So yeah, as I mentioned previously, we have several experiments also designed for the hydropower, so that the students can compare different types of turbines, the efficiency, the design, what they are used for, the modern design, as well as compare the performance and get the basic understanding of the turbine design and using it in real conditions. Okay, so let's have a look at what we have in the case. So I'm not sure that the presentation is working. Can you confirm that the presentation works? No. Okay. Slow. Okay, I see. Yeah, because it seems they experience some internet issues at this moment. Okay. Okay, I think yeah. Okay, it actually works, I believe. Okay, so when it will be loaded in your case, so please also confirm it. In the meantime, I can switch. Okay. Okay, so it's good for some of people. Anyway, so let's wait. In the meantime, I can demonstrate it to you live. So what we have, let me just switch to other camera. Sorry. It's actually interesting. So this is typically how the case looks like, as you can see. And it supplies all possible components as well as a manual. Our base unit. From the ready-to-go series, as you can see, because we can plug up to 3 different modules. Also a turbine, and a turbine housing with the 2 different inlets and 1 outlet, with a set of manometers. So the turbine is interchangeable, and we have several designs, which can be easily changed just by unscrewing these two screws and removing all this plastic housing. So to the turbine, there is also a disc with a permanent magnets attached. To which we plug a generator. So therefore, by the rotation of the permanent magnets, we also create a current in the generator, which also consists of several coils, capacitors installed, as well as the diodes for the protection. Okay, I think it's good. Let me see whether it works now. Okay, so I hope it works in your case, and we can start going from the components once again. Okay. No, I still experience some problems, unfortunately. Okay, then I have to do it live then. So yeah, the base unit, the turbine module can be also installed on the base unit by simple plugging. And we have 3 different turbine designs starting from the regular water wheel to the cross flow, and the Pelton turbine, which is somewhat a combination of the cross flow and the water wheel, which is the most commonly used turbine at this moment. So also, this tool to separate the inlet into the two different outlets so that we can connect it here, for example. A volumeter, which is capable of measuring the flow in liters per minute as well as other units. So our AV module, which we are using for the measurements, the current as well as the voltage, a buzzer, a motor module, a lamp, also, and the resistor module. As well as another lamp. Okay, so I will once again post the link. So please open this link, because at this moment I'm experiencing some technical problems with the presentation, and therefore I cannot share it in a meeting, unfortunately. Okay, I believe we went through all of those. Okay, yeah, we have a flow box which is designed to simulate the water hoses of the diameter. So the students can also see this between the water equals outtake from the different hoses. And example, we will also see it turbine in action. So you can see by assembling the whole setup and connection the water source, the turbine starts to spin. Okay, so for this experiment we need a water intake container which has an incline bottom. Oops, I forgot that I need to. And by changing the different hoses, the students can also observe the difference in terms of how much time it takes for the vessel to drain, so which is quite useful for the representation of the water dam and the amount of the water flow. So here we can see 3 different turbines, as we mentioned. So the turbine is installed into the by removing the plexiglass housing, and then by screwing it back with the 2 screws. And by turning on the water and opening both of the inlets, because in this case we need 2 different inlets, so for the most effective rotation of the generator, of the water turbine, the generator starts producing electricity, which you can also see by the rotation of the motor module. Okay. So now we will go to the wind energy. Which has this, in principle, the second potential in terms of the energy production from all of the renewable energy sources. And we will have a look how it actually works. So before we start, I would like to remind to all of the newcomers, so please follow the link which you can find in the chat, and please open the presentation. Otherwise, you will be also experiencing some problems that I have at this moment. Okay, so let's have a look on the video. Yeah, I'll just switch also. Oops, no, that was a bad idea. So basically in this video you can see how the design of the rocket wind turbine also enters the design is, and as well how the wind turbine works. So I really hope that you can also hear the audio track, because unfortunately I cannot switch it on. Yeah, but in this case, the main idea is that the modern turbines are smart enough and they follow the direction of winds. They can also regulate themselves, not just by yawning and following the direction of wind, but also by regulating the so-called pitch angle, which is the angle of attack. So the difference between the angle of attack of the turbine as well as the intersection of the rotor blade. And unfortunately for the wind turbine, there is a theoretical limit which cannot be overcome in terms of efficiency, which you will see right now. Yes, so this theoretical limit is known as the bad side. Okay, so yeah, as you can see, the capacity rapidly and quickly increased since the 2000 millennium, and you can see the increases in a factor of 290 in this case. Leader is still China, with the United States on the second place, Germany finishing the top 3. In this statistics, you won't find, for example, Denmark, which is quite an interesting country in this case. On a windy day, they can supply themselves only by offshore wind plants. So roughly the 50% of the energy production in Denmark is only from the wind energy. Okay. Let's have a look on the content as well as our product, which is called the leXsolar Wind Professional. So the focus group is still the same. It's designed for the electrical engineering. There's also the training in electrical engineering, physics, renewable energy, and environmental science. And the students get the understanding how the wind turbine works. So what are the main influence on the efficiency of the wind turbine, so what kind of rotors to use with a flat profile, with an optimized profile, also how the number of blades, as well as the rotor geometry influences on the efficiency of the energy production. So here you can see a look on what's inside of the case. And like our professional series, it's also equipped with a professional base unit. However, we will start with a wind turbine module, which consists of two parts, and it's also can freely rotate. So within a 360 degrees, as a typical, also as a turbine model as well. So as a real turbine module. So it's equipped with a finger guard to protect. So for the security reasons, so to protect the fingers of the students, and the several rotor sets with different kinds of blades, different number of blades. The flat profile with an optimized profile with 3 or 4 blades, so also F2 can be used. And the wind machine, which we use for the simulation of the wind, which in combination with our power module can simulate different speed and velocities of wind. The next rotor present is so-called the Savonius rotor, which is a vertical axis wind module. It's similar. It's also called a drag rotor because it experiences less drag in the direction against wind rather than direction towards wind. So, and if you take a look from above, you can see that sort of looks like the letter S. And due to its blade location, because of its blade location, it's also called a vertical axis wind turbine. Also, already familiar to us, a potentiometer, which is the potentiometer motor module, which is the simulation of the consumer. For almost the same purpose, there is a resistor. And an I-beam module, which we use for the measurement of the current as well as the voltage, or the simultaneous measurement, and also our power module, which is capable of the energy output from 0.5 up to 12 volts in a step of 0.5 volt. A base unit that I mentioned from the professional series, which can fit up to 4 different modules. And a laser RPM counter, which is capable of calculating the repetition per minute of some rotor blades. And as well as an anemometer, which is used for the measurement of the wind speed. So now let's have a look on a couple of the examples. So for this experiment, we will need 2 different rotors. So the one with which is a Savonius rotor, and the second, which is a 3-blade rotor with blades with an optimized profile. So you can see the blades are just simply plugged into the rotor. Then the turbine itself is installed on the module, and wind machine is also connected to the power input. And of course, for the safety reasons, everything is indicated on the wind machine, and it's also using the safety 4mm plugs. And in this experiment, we are going to measure the voltage, the output voltage of the wind turbine. So keep in mind that the wind machine uses a 12 volts. And you may also remember which is the theoretical limit of the efficiency of the wind turbine is 59.3%. And the goal of this experiment is to compare the efficiency of the three-bladed rotor, the most common wind turbine, and the Savonius rotor, which is a vertical axis rotor. So the maximum value which was reached was around 5.6 volt for the three-bladed rotor, or for the horizontal rotor if you want. And for Savonius rotor, you will see the value now. And it's around 0.7, 0.8 volt, which is much less effective than a three-bladed rotor. However, in some cases, Savonius rotor is often used, in spite of the fact that it's less efficient, but it's more reliable and more stable. So this is the reason of using the Savonius rotor. In the next experiment, we will see how the pitch angle influence on which influence it has on the efficiency of the rotor turbine as well. And as I mentioned previously, the pitch angle is a deviation between the angle of attack and the intersection of the rotor blade. And by variation of it, so typically the turbine align this angle themselves, the pitch angle with respect of the upcoming wind. And then they can maximize their efficiency, but at the same time stay in the range of the working range. So which is also important in the case of storms, for example, that they either will be working or the pitch angle will be chosen so that the rotor is feathered, the blades are fluid, and the generator is basically shut down and does not produce any energy. So this is also done for the safety reasons. So as you can see, there are some marks on the rotor blades which we need for the RPM counter. And yeah, so here in this experiment we will confirm, sorry, not confirm, but compare two different, so rotors with two different pitch angles of 25 degrees and 50 degrees. So the power module is set on its maximum voltage output, which is 12 volt, meaning that we are using the full speed of wind, which we can possibly produce. And in this case, we we're going to observe two quantitative values. So the one will be an RPM, so the RPM or repetition per minute. So please keep in mind that we are using three-bladed rotor, meaning that this value has to be divided by the factor of 3, and as well as the voltage, which is similar to the previous experiment, is around 5.5 volt. So by the direction of the laser RPM counter on the smart, it reads how often, so how many repetitions per minute are performed, which is around 18 or 19,000. So this was three-bladed rotor with a pitch angle of 25 degrees. So now we will be using the three-bladed rotor with a pitch angle of 50 degrees and compare the values that we observed previously for the pitch angle of 25. So as you can see, the voltage is roughly 3 times less already, as well as the RPM of the rotor. So meaning that keeping in mind those values, so not those values, but these factors like pitch angle, number of blades, it's quite important for the design of the wind turbine and the understanding of its working principle, as well as how to maximize performance and efficiency. Okay, so are there any questions up to this part? So please answer on chat, and if you have any questions, please ask me. Remember to not hesitate to ask at any point. Okay, good. Then we are finished at this moment for the most popular renewable energies and renewable energy production, and we will go into towards the direction of topic of energy storage, where we have two different topics to see, which is one is regarding the fuel cells, and one regarding the different type of accumulators, batteries, and etc. Okay, so let's start with a hydrogen fuel cell and its working principle. So let's see the video. Okay, so it seems there is no audio track. Oh, no, there is. Okay. Okay, so after the electrolysis was performed, we need to supply our fuel cell with the two different gases, which is obviously hydrogen and oxygen. so the main principle is that we need to supply our fuel cell with hydrogen and oxygen, and in between, so between the cathode and anode, so between the two electrodes, we also have a semi-permeable membrane, which is capable for letting only the protons to go towards the oxygen. So nowadays, fuel cells are found on application in many areas, especially regarding vehicles, so they can be used in different sorts, starting from the submarines up to the conventional cars, well, not conventional, but more traditional vehicles like cars or bikes or boats, and so on. And for the car, in order to be supplied with the hydrogen, so there are two different methods which can be used. So the first one is also, so for example, the swapping of the nitrogen, or sorry, of the hydrogen tanks, or by recharging it at certain hydrogen stations, or by using also electrolyzers to produce the hydrogens themselves. So now let's have a look on our product, which is called the leXsolar Hydrogen or H2 Professional. So which has the main goals to let the students and to get them some understanding on the working principles of fuel cells, and not only the hydrogen fuel cell, but also on the ethanol fuel cell or direct ethanol fuel cell, also to distinguish the working principles not only of the fuel cell but also of the electrolyzer, stacking of the fuel cells, and as well its efficiency. So once again, let's have a look what we have inside. And we start with this hydrogen charger, which is an electrolyzer machine capable of producing hydrogen and later storing them in such sticks, which are the metal hydrates, which have metal hydrates inside, or a porous metal framework to which hydrogen is binded and stored. So every stick of the size about a regular battery is capable of storing around 10 to 30 liters of hydrogen. Also, the next is hydrogen storage module, which is two vessels, gas titles, and PEM fuel cell, which is a proton exchange membrane fuel cell, which has a polymer membrane in between two different electrons, which is semi-permeable only for the hydrogen, for the protons, and as well as the electrolyzer for the electrolysis of water and later on production of hydrogen. The next fuel cell available is also an ethanol fuel cell, which works on the same principles, because the ethanol has a specific energy more than a hydrogen, however, which is less than a methanol. So the material and liquid which was previously used, but however, due to its but because it's dangerous to the human health, so it was rejected. So therefore, the ethanol is used at this moment. So it's also based on the same principles, and by oxidation of the ethanol, the hydrogen is produced, as well as the water is the waste and the CO2. Then we have some modules which are already familiar to us, which is a potentiometer, motor module, for the simulation of the consumer, and our base unit, which is used for the stacking of the models. And as well as a solar cell module. Why we need it later? Why we need it? You will see later. Okay, so let us see the first experiment. So the first example experiment, which is a characterization of the electrolyzer and therefore the production of hydrogen. For this experiment, we will need our electrolyzer, hydrogen storage tanks, hydrogen and oxygen storage tanks. So which are also filled with water up to a certain amount. A lamp, which is also used for the simulation of the sunlight for the solar cell. So first of all, electrolyzer is filled with water. And the tubes are also connected to it. And also, why we are using the solar cell in this experiment? That because that's a perfect candidate for it, as either a solar cell or a wind turbine. Because quite often they are also located somewhere like an offshore wind turbine power plant, or solar cells that also produce an excess of the energy which cannot be stored or transferred. So for this purpose, an electrolysis can also be performed directly by the site of the power plant, and the energy can be stored in terms of chemical energy, and in this case as a hydrogen. Because the main losses and the main problem of the renewable energy power plants is it's energy losses, so due to the transport, because unfortunately the superconductor power lines are still yet to be produced, so that it does make a lot of sense to store an excess energy that cannot be supplied to the consumer in some sort of energy storage plants. Then we will also need a potentiometer for the regulation of the voltage and current, because in order for the electrolyzer to split water, we also need to overcome a certain potential difference, which is for water is 1.23 watt. And then, after connecting everything in the correct order, so we can start the electrolysis process. So by turning on the lamp, the solar cell will start to produce electricity, and then by adjusting the potentiometer, we can get the values that we need, which will be recognizable by the formation of the hydrogen gas inside of the gas tanks. And yes, and if you wait some time, you will also see some gas bubbling through the water, and it later on will be stored in these gas tanks. And in the meantime, students also record the IV characteristic of the electrolyzer. The second experiment is an application of the hydrogen charger, which is this machine. And here you can see also this hydrogen stick that we also mentioned previously, as well as a reductor with a tube, so with a hose attached to it, and a fuel cell, and a motor module which also acts as a consumer. So the hydrogen charger is filled with water, connected to the electricity. It uses its own power input, and then the hydrogen stick can be attached to it, so by the screwing motion. And for such a stick, it takes in between 2 to 4 hours to get to be completely filled. The fuel cell is later installed in the module, because the same module was used for both the fuel cell as well as the electrolyzer, and then the tube from the hydrogen stick is attached to it. And the second tube is for as exhaust for the waste, and which is in the case of the hydrogen is only water, since we use an ambient oxygen, which later on recombines with hydrogen and forms water as a waste. So by parallel connection of the motor module and the fuel cell, we can get the motor working. This experiment can also be extended, so for example by stacking a series of the fuel cells, and also the students can understand what's the difference between the parallel or series connection of the energy storage materials. Okay, so now from the hydrogen as an energy storage material, we also move to the more traditional for us, which is batteries, which are batteries. I think we will skip this video. If you want, you can also see it later on. So it was about the working principles of electrical cars, which we will also cover later on in the next topic. So, and you can see the total sales of electrical cars increases quite dramatically in the past. Well, here is the graph is up to 2015, so in the past years. And with China as a leading consumer, and so European Union, as well as the United States and Latin America, is a little bit behind. Okay, so yeah, there are several kinds of electrical cars available. So the one is so which can be completely electric, so or battery electrical vehicles, so with abbreviation of BEV, as well as a plug-in hybrid or conventional hybrid. So when a battery is also filled by, well, not filled by, but charged by the motor working on a fossil fuel as a generator. And the product which we offer, which is called the leXsolar EMobility Professional, is designed for the purpose also for the specific purpose, so that the students can also understand the working principles of batteries, so the main physical laws, as well as to be familiar with the different types and chemistries of batteries, like nickel metal hydrate, lead acid, lithium ion, and a lithium polymer, or also capacitor and a fuel cell. In this case, the fuel cell which is included is a hydrogen fuel cell. Yeah, so the main experiments can be divided into the several groups, which are charging and discharging of batteries, because as you may know, the batteries, they possess different characteristics, electrical characteristics, meaning that the current output, voltage output, and power output differ from the battery chemistry type to other battery. Therefore, the charging protocols cannot be used the same for the different kinds of batteries. Some types of batteries use CC or a constant current. Some types of batteries use CV or a constant voltage. And nowadays, most of the batteries use a combined so-called CC-CV or constant current, constant voltage charging protocol. As well as the efficiency of the batteries, their characteristics, and how do they perform in a real application. So we include 5 different battery chemistries in our kit, as well as a capacitor as a second type of the energy source, and a fuel cell. So now let's have a brief look on the components. So most of the modules are already familiar to us, therefore I will skip them. And I will just stop on some that you haven't seen, which is this charger module, which is specifically programmed to charge several kinds of batteries. So starting from the nickel metal hydrate, nickel zinc, so lithium iron phosphate, lead acid, etc., etc., as well as to be used as a primary energy source for the electrolyzer and charging of the supercapacitor. So here we can see the reversible fuel cell, and unlike the fuel cells that we demonstrated in a hydrogen professional, this one is a combined one. So that means it's a combined electrolyzer and a fuel cell in one device. Also, lithium polymer battery, lead acid battery, or the most traditional and conventional battery, which are still widely used in accumulators of the cars. Lithium iron battery with the chemistry of lithium iron phosphate, which is the regular size AAA. And electric car which is a model of electric car, which however operates on this and relies on the same principles as a regular battery electric vehicle. Also, the model which uses 3 nickel metal hydride batteries, so serially connected in series, and a cable for terminal sensing, since almost every model is has an integrated PTC element, so a positive temperature coefficient element, and this model allows us to measure the internal resistance of the modules. And also quite familiar to us, AV module and several multimeters. Okay, so let's have a look on the example experiment. Which is about a 4-point measurement or for terminal sensing. And for this experiment, we will need basically any battery, because it reproduced for every battery chemistry. So, but as an example, we will take a lithium polymer. A cable for the 4-point sensing for yeah, okay, so sorry, 4-point measurement. A resistor. So resistor module also allows to plug in up to 3 different resistor plugs in parallel. An AV module. And a couple of multimeters. Because the main difference of the 4-terminal sensing and the conventional measurement of the voltage and current, that it's instead of 2 cables, we are using 4 wires. And that allows us to measure the internal resistance, in this case of the PTC element, and as well to get separate measurements of the voltage and current. So you can see when the circuit is not closed, the measurement values, measurement voltage values are the same from the PTC element as well as at the end of the circuit. However, if we close the circuit, so we can see some deviation, which is due to the internal resistance of the module. And by taking this deviation and dividing by the current measured in the end by the AV meter, one can also find the value of the internal resistance or impedance of the module. Okay, so now we'll have a look on a more visual experiment, which requires all possible energy storage devices provided. So in the first part, we use the capacitor module, which needs to be charged. So I would like to remind you the main difference between capacitor and regular batteries, that the capacitor, its capacity is much lower than of the regular battery, in spite of the fact that this one is a supercap or a supercapacitor, so with a capacity of approximately 10 times larger than a regular one. But the supercapacitor is, however, capable of delivering quite large power output at the same time. And this is exactly what is performed in this experiment, that we see how the different battery chemistries perform by controlling this electrical vehicle, because in this case the energy is supplied from the different sorts of batteries. So the one can perform it not only as a fun experiment but also as a quantitative one. So by doing sort of a test track, since you can rotate the wheel axis, that the car will be moving in circles instead of the straight line. And then by calculating the number of circles it has performed, and as well as measuring its time, the one can find the most effective type of battery for the electrical vehicle. The same operation can also be performed for the fuel cell. So in the first measurement we have a lead acid accumulator, lead acid battery. And it takes roughly 24 seconds for it to perform the 4 circles. So we decided to take 4 as a reference point. So the next one is a lithium polymer battery. And if you remember, the lead acid had approximately 2.2 or 2.3 volts. So this one has 3.7. So we're expecting the car to move faster. And this is exactly what happens. And we can also perform it for the different, well, for every single battery type. So let's just have a look on a last one, so which will be a supercap. It is not, however, charged completely, but at the same time it will be sufficient to see how it performs in real life. So as you can see, the first cycle was quite fast, but then it started to slow down because the voltage output is not constant, and it also decreases within during the time. So it cannot even perform the complete 4 circles, and it stops somewhere in the beginning of the third one. Okay, so now we'll be moving towards a more advanced electrical vehicle. So, for example, here you can see the main components of the fully electrical car. so which has a electrical motor, which can be either installed as a traditional car, so somewhere on the back or on the front of the vehicle, or installed into the every wheel frame, or to the every pair of wheels. So yeah, so somewhere on the axis. Also the battery pack and battery management system. I guess we will skip also this part how electrical car work, because it's quite well known. And we will go directly to our product. We also offer a model of the electrical car, which we are calling the EMobility Instructor, which is our model of the transparent and educational model of the electrical car. So it's targeted to the automotive engineering as well as the electrical students of the electrical engineering, and the students can investigate the component of the real electrical vehicle, as well as understand the main working principles, records quantitative characteristics of it, and as well it's actually quite easy and fun to drive as well. So we have several measurement possibilities for this car, and then we'll discuss them. Okay, no, sorry. Yeah, so we have several possibilities. We can either measure them from the dashboard manually, because we also have a dashboard installed on the back of the vehicle, which we will see later on. Or we can measure it by from your mobile phone, because it's also Bluetooth compatible, or by the computer, because there is a CAN bus installed, meaning that the one can gather data from battery management system as well as from the motor controller. So we offer several possible options. Here, for example, you can see the screenshot of from the motor controller and some of the characteristics that it records. So now let's have a look on the card itself. So here we can see how it looks in real life. I'd have to say it's a previous model, so there are several changes already applied to it, but they're quite minor, so that you probably won't even notice them. And let's have a look. Yeah, so in front I have an ABS bumper. Then right now you can see the battery pack. The battery pack consists of 32 lithium iron phosphate batteries in a configuration of 2P16S, meaning that 2 cells are installed in parallel and 16 in series. So giving the nominal voltage of 51.2 volts and a total capacity of 30 ampere hours. Also, the battery management system is installed so that every pair of cells is controlled and protected from overcharge, over or under voltage, over or undercharge as well during the charging process, as well as during the operation. So this is our dashboard, or also control panel, which offers a possibility to control the car when it's installed on a special stand in order to work in lab conditions. because all of the experiments that can be performed for both driving, in a driving mode, as well as in the laboratory mode. So yeah, as I mentioned, it's a transparent model, so that you can see all of the components like a powertrain, exactly, so the battery pack, management system, etc. And here is exactly the dashboard, so which offers also several measurement possibilities. The one can measure, for example, the temperature or the voltage of the whole battery or of the certain cell pair. Also, there is a USB port for the access to the BMS data, so to the battery management data. A monitor, so that most of the values can be also seen on this monitor, and the CAN bus also for the data acquisition from the computer. So that's that. The battery management system controls battery during charge and operation, charge, discharge, and it offers a passive balancing feature for the cells, meaning that it's a resistor-based balancing. And so we can acquire certain data, like the voltage, state of charge, the battery current, also the voltage of the whole cell or of the whole battery pack or of the certain cells, and many more. So now to the technical specs. Yes, it is a card, but yes, it's also fast. So the maximum speed which can be reached is 75%, which is, however, also can be limited for the safety purpose. And it accelerates to 75 kilometers in 5 seconds. There was also integrated regenerative braking system. So meaning that the part of energy is also returned to the system by braking. So now let's see the video of cart in operational conditions. It's a bit slow. So yeah, you can see it accelerates quite fast. And because of the low center of gravity, this one is also a fast one. And because the BLDC motor is used, the maximum torque is also provided right from the cold start. About the motor, yes, so it is a 5 kilowatt, so nominal power 5 kilowatt BLDC or brushless direct current motor, which is rather fast. And as for all of the leXsolar products, we also offer the complete set of the experiments, and our current experiments include charging and discharging of the lithium batteries, also operating the battery management system, also the power measurement of the drivetrain, excuse me, and understanding the mechanism of the recuperation, as well as understanding how the electrical BLDC motor works, how the rotor determines its position, how the whole sensor work, and so on.
My name is Stefan Zipser. I'm Professor for Automotive Electronics and E-Mobility at the University of Applied Science in Dresden. We use the electric car from leXsolar understand experiments we often see. To design and has free access to key components of the code. The EMobility instructor comes with extensive documentation and ready-to-use exercises for your classes. Analog voltages and digital communication interfaces are neatly aligned and accessible on the dashboard. In this way, students can safely measure battery cell and electric drive voltages during operation and log on to the PC. With the provided auto software, students can gain a deeper understanding of the operation principles of an electric drivetrain. And battery parameters can be changed to increase the electric car's performance. Test drives on the track of the study exercise into an exciting activity. The mobility package includes a laptop, a pre-installed software to log live motor control and battery management data once.
Okay, so now the connection is restored. Yeah, I'd like to excuse, but it seems that we experienced some small internet problems today. Okay, anyway, so now we can continue. So yeah, are there questions? Any questions so far? Please write in the chat. So we have the last 3 topics to cover, which we will do roughly in half an hour. So, okay. So let's go to the next topic, which is excuse me. So we're going to the next product, which is called the SmartGrid. So all of the above mentioned products only make sense when they work together and when they work and when the power grid is capable of fitting them. That means that in order for the efficient use of the, for example, sun power plants or wind power plants, we also need to change the running system. Because by using the sun and wind or hydro energy, we also create lots of small power plants, which should also work in cooperation with existing conventional power plants, nuclear plants, coal, gas, whatever is used. Also should be kept in mind that the production of energy is different for example, for the wind turbines or the sun or the solar cells, simply because of the timing. That should also be kept in mind. Also, the distribution of energy within the households, and especially for it, so we designed a product which is called a SmartGrid. So let's first of all see a short video also about the SmartGrid.
Our current electric grid was made for a simpler time and simpler energy needs. For decades, utilities have produced electricity in central power plants, distributed it to your home, and then sent you the bill. However, the way we live has changed, and this limited one-way interaction cannot meet the more complex demand for energy in the 21st century. So now, our electricity grid needs to change too. It needs to become smarter, enabling two-way communication between you and utility, increased flows of information and energy. This is the smart grid, but how will it work? Smart meters and sensors will provide rapid two-way flows of data, which will allow both you and the utility to know exactly how much energy is being used at any given time. With a smart device, you will be able to monitor your energy use and make changes instantly to control your energy costs. The smart grid will be a more reliable and responsive grid where power failures can be managed and electricity restored at the push of a button. It will be a more flexible grid, which will be able to integrate renewable energy and electric vehicles into the network. This is part of a major transformation in the energy industry. The power is moving from the center to the edge of the grid. Previous passive consumers have become active participants in the network. Customers may even become producers of power, feeding surplus energy back into the grid. So the smart grid does not just supply you with electricity. It combines the latest developments in energy, communications, and information technology to bring real power to your people.
Okay. So yeah, the smart grid can provide a sufficient amount of energy as well as minimize the cost for its transfer, as well as the production, and as well new technologies can be applied, because what we were talking about the electrical cars, and the efficient use of the electrical car and efficient charging of the electrical car, it's of course to charge it by the renewable energy sources. Otherwise, what is the purpose of using those electrical cars? And this can be performed by charging it during the day from the fast charger, or from the energy generated by the wind or solar power plants. And at the same time, by connection of the electrical vehicle back to the grid. So there is a technology which is called V2G, or vehicle to grid. The demand, so the typical evening demand, which is a rush demand, and the maximum one, can be also satisfied. So now let's have a look on our product, which we call leXsolar Smart Grid. Which is also designed for the same target group as was previously mentioned, and which also contains the complete all of the materials and all of the models that one need to simulate a smart grid. So it does allow you to make a comparison between the regular or conventional power plant and a power plant which is based on the renewable energy sources, and as well as make a combination of them also to introduce the energy storage into the grid or into the household. Yeah. Okay, so let's have a look on the components. Most of them are also already familiar to us, but nevertheless. So there is a solar cell, a large one, once again, a light bulb, potentiometer, motor module, which are used for the simulation of the consumer, a wind turbine, similar to what was present in the wind, also several rotors, a diode for the unidirectional flow of the energy, capacitor as an energy storage material. So the maximum point tracker that we also see in the PV Professional, and the base unit. But unlike other products, here we have two base units, so which are able to fit up to 8 modules. So also EV and the fuel cell and other battery types. Okay, so let's have a look on the example experiment. I'll briefly explain them. So in this case, we are simulating the energy consumption of the, for example, regular household or industrial building, which is where the energy is supplied from the grid, and at the same time, this building or the house uses energy storage, and in this case, which is a fuel cell. So we can even do a series of our consumers, as you can see here, where we have a motor module and as well as the 2 lamps installed. And by measuring the voltage, we can see how much of voltage is consumed by the 3 households. So we can also include the solar cell in our grid. And use excess energy, which is created by the solar cell, for the electrolyzer to split the water and therefore produce hydrogen, which is used as energy storage, as a chemical energy storage, and can be used later when the demand of the electricity is, for example, large enough, or why not to use an excess of energy to be stored and not going back to the grid or even dissipating completely. So here you can see that we have an excess of energy. So in comparison to the first measurement, and therefore we can use this excess of energy in order to power up our fuel cell. Also, in the smart grid, the excess of energy can be also transferred. So, for example, produced by the solar cells or wind energy can be transferred back to the grid, and later on sent to the sold to the electrical companies directly from the consumer to the electrical companies. Okay. So let's have a look on the second model experiment, which is stability of the electrical grid. So when we have a conventional power plant as well as a photovoltaic solar cell. So you can also see these two models, which does look like a power line, and it is in fact a power line. So which also simulates the grid lines or the power lines. In this case, there is a small resistor, so there is a resistor installed, so that simulates that some energy is lost due to the heat during the transfer. Because for every several kilometers where we transfer energy, we also gather some losses. In this experiment, we also simulate the two households, which you can see by the two lamps. And the one of the household is supplied by the conventional power plant, and later on the energy is transferred to the second home, to the second house. However, the second household is also equipped. Let's suppose it's equipped with a solar cell installed on its roof. And we can simulate in this experiment the behavior of the energy consumption during the day, starting from, for example, from the night to morning and up to the evening, and etc. And as for many solar cells, in this case, also using the MPP tracker, so to find the maximum power point of our solar cell in order to maximize its efficiency. And we have a couple of smart meters which also measure the voltage as well as the energy consumption of those households. Sorry, not the voltage, but the wattage of power. So, in order to simulate the behavior of the solar cell with respect to the sun, it can be rotated also on this scale, which also simulates the movement of the sun relative to the solar cell. And of course, we need lots of the sharp plugs to complete the circuit. So the circuit goes from the left side of the upper base unit to the right, and then from the right side of the lower unit to the left. And the first household is currently supplied by the conventional power plant, which is simulated by our power module. And if we measure it right now, so that the power of the first household will be larger than of the second, because there are also some losses applied to it. So we can also, so we assume it's a night or early day, and there is still no sun on the sky, and therefore the solar cell is not working, and therefore the current flows from the power plant to the first household and to the grid module, via the grid module to the second household. And in the meantime, the solar cell does not produce any electricity yet. But then we can switch the lamp and also move the solar cell. And the voltage in the second household is lower due to the losses, and as well as the consumption from the first household. But if we do, however, the move and adjust our solar cell with respect to the sun, so that it will start generating energy, the second household will be partly supplied from the energy generated by the solar cells. Which you can also see in the quantitative values. And then, if we assume that it's somewhere around noon, and the sun is directly above the solar cell at its peak power, then the excess of energy can be even transferred to the second household. And we can simulate this process hour-wise. Okay, so this was a smart grid. Now we will move to the last section for today, which is our environmental section, which is dedicated to the bioenergy production and fuel. So let us see once again the short video of the different kinds of biofuels. So I hope you can hear.
Like gasoline, diesel, and jet fuel. Ethanol is an alcohol formed by fermentation. It is used as a replacement for or additive to gasoline. Biodiesel is an oil produced by extracting naturally occurring oils from plants and seeds. Biodiesel can be combusted in diesel engines or blended with diesel fuel. Biofuels are grouped in 3 categories based on the type of feedstock used to produce them. First-generation biofuels are produced from food crops. For ethanol, feedstocks include sugarcane, corn, maize, and others. For biodiesel, feedstocks are naturally occurring vegetable oils such as soybean and canola. Second-generation fermentation plants. This material is more difficult to break down through fermentation and therefore requires pre-treatment before it can be processed. Third-generation biofuels are produced using the lipid production from algae. In addition, the term advanced biofuels is used to describe the relatively new technological field of biofuel production that uses waste, such as garbage, animal fats, and spent cooking oil to produce liquid fuels. Biofuels are currently the only viable replacement to petroleum transportation fuels because they can be used in existing combustion engines. This is an increasingly important advantage with growing concern about the environmental impacts of fossil fuels around the globe. Biofuels can also help provide energy security in regions that do not have hydrocarbon resources but do have suitable agricultural conditions. While there is some dispute over just how renewable biofuels are, it is generally accepted that the crops used to produce them can be replenished much faster than fossil fuels, which take millions of years to form. Concerns about biofuels are usually centered around the fact that they are an agricultural product. Producing these biofuel crops can mean competition with other natural resources, particularly land, food, and water. First-generation biofuels use only edible crops, which has led to biofuel crops displacing food sources in certain regions and subsequent spikes in food prices. In many regions of the world, subsidies are provided for these crops, which only amplifies these issues. In addition, increased agriculture of any form comes with concerns of deforestation and biodiversity loss, as well as water and fertilizer use, which have environmental and climate impacts all to their own. That's biofuels.
Okay, so I should probably only add to this video that nowadays there is a fourth generation of the biofuel. It's created. Okay, so let's have a look what we offer in this case, and on our solution, which we're simply calling also the leXsolar biofuel. It's mainly oriented on the students, on people, so in terms of the chemical engineering, chemistry, as well as the physics and renewable energy. And there are several experiments included, and the one is about producing a biofuel, and in this case, it's a bioethanol, and as well as a biodiesel, so which we also call FAME, which is a fatty acid methyl ester, so which is a product of the esterification of the fatty acid. Exactly. So this is one of the experiments, and the bioethanol is formed by the fermentation. Now we're using the sugar with yeast, and this mash is first of all fermented and distilled in order to produce the ethanol. So in this case, the students can also understand the basic chemical procedures like distillation, and later the produced ethanol can be used for the provided ethanol fuel cell, direct ethanol fuel cell. Okay, so let's have a look on the components. So once again, everything familiar, which is a potentiometer, motor, and an ethanol fuel cell, so which operates on the basis of the oxidation of ethanol and formation of hydrogen, which is later consumed, and water and CO2. An ordinary flask, which we also use for the fermentation as well as the distillation. Yeast, which we need for the fermentation. A thermometer for the temperature measurement, and several accessories for the distillation and later use, like for example an airlock, which is used for the distillation in order to prevent the mash, well, not for the distillation, sorry, for the fermentation, in order to prevent the fermented mash from any contact with air, with ambient air, with oxygen dissolved in it, so that no part of the mesh is oxidized. So it's typically filled with water, and therefore the CO2, which is also leaving the mesh during the fermentation, can also go out from this airlock. Then there is a couple of areometers, where the one is gradated for the measurement of the sugar content of the mesh, and the second for the alcohol content of the finally distilled liquid, as well as the pipettes for the testing, and the test tubes for the sample, for the testing, and for the taking the process. A condenser that we need for the distillation, which is filled with water. Therefore, the ethanol vapor, it cools down, and then as the drops are collected in a cylinder or a beaker. Okay, so let's have a look at the experiment. And in this experiment, we use the sugar solution, so we use the sugar solution, or just dissolved sugar in water, and the yeast. So first of all, we dissolve sugar, then add yeast for the fermentation. And then it's also secured with this airlock, as I previously mentioned. So you can see the fermenting mesh at this moment, and you can see a CO2 bubbles coming from the bottom to top, and leaving this airlock by dissolving in water and then going out into the atmosphere or staying in the water. And then by setting up the apparatus for the distillation, so and the base unit stand and everything else is also provided and is in the case. As well as a Bunsen burner, it's also provided, which you can see right now in the video. Then by putting the condenser into the flask. In this case, for the simplicity, we do not use the condenser with a direct flow, but rather a storage type condenser, so where the water is filled and it stays there, so it doesn't flow through the condenser. Okay. So the thermometer is installed, so typically around the exhaust, so that it does definitely measure the temperature of the vapor, because it will be condensing on it. And then the apparatus for the distillation is all set, and one can light up the burner. And after some time, the ethanol starts to evaporate from the mixture and can be collected in some vessel. And with this experiment, we can produce ethanol with a concentration up to probably 60%. So besides this, so some of the experiments I also created for the production of the biodiesel using once again the fuel cells, the ethanol fuel cells, and so on. So always keep in mind that the experiments which are shown are just examples of experiments, and there are many more which are also provided. So now we are going to the bioenergy. And let's see once again the short video about what is bioenergies.
Biomass energy, or bioenergy, refers to energy produced from organic matter. Biomass is primarily found in the form of living or recently living plants, as well as waste. The term feedstock is used to refer to whatever type of organic material will be used to produce energy. Different feedstocks will have different physical compositions, but generally all feedstocks include varying amounts of carbon, water, and organic volatiles. For energy production, a feedstock must be converted using one of many processes. Some common biomass conversion processes include combustion, the process where feedstock is burned in the presence of air to release heat. What happens when you start a small campfire with wood? Combustion can be used to heat steam for electricity generation as well. Gasification, the process using heat, pressure, and partial combustion to convert feedstock into a combustible gas mixture called syngas. The syngas can then be used in place of natural gas for heating, electricity, and other uses. Pyrolysis, the process of heating feedstock at high temperatures in the absence of oxygen. Since no oxygen is present, the organic material does not combust. Instead, the chemical compounds decompose into three forms: a liquid called bio-oil, a solid called biochar, and a syngas, which we talked about earlier. Anaerobic digestion, or biodigestion, a process where bacteria breaks down organic material in the absence of air to create biogas, which can be captured and burned to produce energy. The remaining byproduct is called digestate, which is a great fertilizer. Fermentation, the process of converting a plant's glucose into an alcohol called ethanol through the use of yeast. The ethanol is a liquid fuel that can be used as an automotive fuel. It is important to note that certain feedstocks are more conducive for some biomass conversion processes over others. The determination of which feedstock and process will be used is determined largely by the availability of resources and the desired end form of energy. Prior to the Industrial Revolution, biomass was the primary source of energy. Biomass now makes up only a small percentage of total world energy use. However, for approximately 2.5 billion people, it remains the primary source of energy for cooking and eating. The use of biomass is highly contextual to the region in which it is used. Availability of resources, availability of technology, and economic viability are all drivers of biomass use. The environmental benefits and costs are highly contextual depending on the technology and feedstocks used. While some biomass processes, such as waste-to-energy, are touted for their lower carbon dioxide emissions, some processes, such as combustion, release carbon dioxide and particulate matter that are a significant concern for human health. The world's most energy-poor peoples and regions still rely on biomass for the majority of their energy needs. The lack of appropriate ventilation mechanisms for burning biomass is a major health concern and contributes to short life expectancies in much of the developing world. Concerns associated with biomass also go beyond human health. Depending upon the source of biomass used, deforestation, cropland degradation, and land use alteration can all be relevant issues associated with biomass. That's biomass.
Okay, so yeah, this was all about the biomass. Okay, hello. Yes, thank you for coming, but we are almost finished. So yeah, there was a question about the record. Yes, we will provide the record as well as the presentation. So within the next couple of days, you will receive the link either to our Dropbox account or to the YouTube, and you will be able to download the record as well as the presentation itself. Okay, so let's continue. So now we'll move into our product, which we also call the leXsolar BioEnergy. And it's designed not only for the renewable energy production, but also for the students to get an understanding about the so-called urban gardening, or gardening in the urban conditions, as well as an understanding of the hydroculture, of the hydroponics, passive hydroponics in this case, and the formation of the biomass and biogas. So let's have a look what we have in the case. So we have several experiments also designed, which are starting from the beginning, which means we start from the growing seeds and up to almost harvesting them. And we can also produce a biomass and the biogas out of them, and a bioethanol by the same principle that we did. Okay, so what's in the box? We have the same consumer type, which is a motor model in this case, a fuel cell, the hydrogen fuel cell, because as a part of the biogas formation, we can form not only the methane, which we also will be using, and but also we can form the hydrogen, which we can later use in our fuel cell. So the familiar to us already our base unit from the ready-to-go series, meaning that up to 3 modules can be plugged. And expanded clay pebbles, which are, because the method that we are using for the growing plants, it's called a passive hydroponics, meaning that instead of we do not use any soil or something, and we use this expanded clay pebbles, which are inert porous material, which not only provide the mechanical support and stability for the plants to grow, but which also provide water as well as all the nutrients from the fertilizer to the roots by the capillary forces. Fertilizer which also contain all sorts of nutrients required for the growing plants, and a compost accelerator for the decomposition of the, in order to accelerate the decomposition of the biomass. And as well as the gas collection vessel, which is used for the creation of the biogas, in this case it's a methane. And the burner which is used for the conformation of the biogas formation. So yeah, since we're using the hydroponics and we don't use the solars or the sunlight, or we can use a combination, but we're also using the LED, the special LED lamps, which are specifically designed for growing suitable plants, and have a specific spectrum with both red and a yellow and blue part of spectrum, and also several boxes for the growing. And at this time we offer 5 different kind of seeds that can be used. a smart socket with the possibility of automatic powering off, an air pump for the saturation of the roots, so with oxygen, as well as with the air stone, which is sort of a porous stone, which forms lots of bubbles, and therefore our plants are always saturated with oxygen. And also some containers for growing, as well as the EC meter, where the EC stays for the conductivity, electrical conductivity. So this is a TDS meter, which can measure the total dissolved solids by measuring the conductivity, and therefore we can determine which concentration of the fertilizer is sufficient and is the best for the growing of plants. A temperature logger, which is later on used in the experiment where we decompose the biomass. So yeah, in order to decompose for the formation of the biomass, because that can also be used as a heat exchanger, because during the composition we can also observe the increase of the temperature. And as well as scale, and some tweezer, which is similar to the gardening tool. So there are several experiments provided for this case, and the first one is about the plant growth, so that students can also get familiar with the growing of plants, so measure the process for all steps, from the germination of seeds of crops and up to the growth into the more mature state of plants, and also get an understanding how the hydroponics works. So they can measure also stepwise, because unlike our other cases, this one does require some time for the experiment, especially this one takes around from 1 week up to 2 weeks, depending on the seeds which are used. And the second experiment is the formation of the compost, so which means decomposition of our biomass and formation of some things that you can see, some fungi or similar to it, because the decomposed biomass represents by itself, it is a great fertilizer and can later be used once again for growing of plants. Also, one of the experiments is detection of the hydrogen from the fermented mesh. And the detection of hydrogen occurs by plugging the fuel cell, and therefore by the methods that we already know, generating the electricity. And detection, and the last experiment, it's a detection of the methane, which is also formed during the decomposition process. Okay. So yeah, this was all for the bioenergy, and in fact, that was all for our professional line. So if you have any questions, please ask me. So feel free to ask, and I will try to answer them. Because right now we are at the very end of the presentation. So have you got any questions? And about the sample or didactic material, this is a question to the Michael Dietrich, who is also in the chat. So, are there any questions, or it was more or less clear? Also, if you have any questions concerning the OPTs in general, or the possibility to do more of the trainings, so for example, for the specific product, you can also contact the Michael Dietrich. And so, are there any questions? If it's not the case, well, the didactic materials, I believe we can provide. About the sample, I'm not sure. So in order to clarify this question, it's better to contact Michael Dietrich, who should be somewhere around. And or we will contact you also directly in the future. So, and I would like to remind you that in a couple of days you will also receive a link with this webinar, as well as if you want to download the presentation, you can do it as well in order to refresh your memories. So, and I hope, and since there is no questions, it seems to be. Okay. And if there is no questions, no more questions, then I would thank you so much for attending this OPT. That's the first OPT of this year. And yeah. Okay, thank you. I appreciate it. I appreciate your feedback. So yeah, then I would like to thank you so much for finding time and so much effort. And I wish you good luck. And yeah, once again, thank you so much. Goodbye. And with this, we will end right now. So, goodbye.
So, hello everybody. I hope you enjoy the meeting. I hope it was not too long today. I see, I don't see you, but I can imagine you are a little bit tired from all of the topics and all of the meeting, but I hope it was a nice summary of all products what we have, especially for the TVET target range. We would like, I think Dimitri already told you, we would like send you then the link to the presentation, to the presentation. You can use it, of course, for any activities for your customers. And yeah, something what was missing, or you have any questions already, or all is fine for the moment and you need rest, I think. You can send me a mail or a chat, or also use the mic when you want. Hello? So when not, then I wish you a nice evening, and I hope we see us soon, and I hope you can be fixed and decide which kind of sample may be also interesting for your sales activities, that you can be present better to your customers. I wish you a good night, and bye-bye. And meeting for all.